Welcome to this video presentation from the Downtown Science Cafe series titled Follow the Water that took place in Tucson, Arizona in the spring of 2014. The Science Cafe series, focused on the science of water, was organized by the University of Arizona College of Science and Flandreau Science Center and Planetarium. In this presentation from hydrologist Paul Brooks, titled Mountain Snow, Water for Our Thirsty Desert Cities, you'll learn about the importance of snow for the water supply in the American West.
And I want to tell you with a high degree of certainty right now that every one of you who's drinking a beverage, it may be water or any beverage that was made in Arizona, most of the molecules of that water that you're drinking came from snow. They came from snow either in the mountains around here or they came from snow in mountains of Colorado or further north. That's the focus of what I want to get across today, and I want to tell you some of the things that we're doing to understand that. To put it in a little context, this is the average climatology in terms of precip for the continental U.S. And these are average conditions. It doesn't mean that's what the weather's going to be like in any day, but these blue colors and green colors on the east show lots of water, lots of precip, and the western half of the country where we live is pretty red, it's pretty yellow. We know that intuitively. We live here. The West has been growing in large part because it doesn't have a lot of precip. It has a nice climate to it. I'll point out that these areas around here, these mountains in Colorado and further north, the ones along the Mogollon Rim, you can actually see the Catalinas right here and Mount Wrightson in the south. Those areas are the only places where we get much precip in the mountains of in the western U.S. And those small areas, that precip comes mainly as snow. These are the sort of environments that my group studies extensively. We tend to think it's beautiful, but to each their own. Hopefully you'll agree it's important. The federal government agreed that it was important. Starting in the 1930s, it started to put in major dams along the Colorado River, and we hear about the Colorado River Compact and the water that's in these reservoirs stored along the Colorado. It's Glen Canyon, Hoover and Parker Dam are three of particular relevance to the state of Arizona. They're some of the largest ones on. But that's just part of the picture. If you look at the whole Colorado River Basin as an example, there's 70 dams that are scattered around here that have been managing that snowmelt water for use at lower elevations. And this management of water in the West, this management of snow specifically, is what's allowed the West to grow and prosper over the last century, over the last 50 years especially. I want to point out Roosevelt Dam here in Arizona. That was one of the first dams on the tributaries, and it dams the Salt River, and it provided water for Phoenix. If you look at the state seal for the state of Arizona, the Roosevelt Dam was completed in 1911. In 1912, Arizona became a state, and on the state seal is that image of Roosevelt Dam, explicitly recognizing the importance of controlling that snowmelt from the mountains. And then the 5 C's of Arizona, the beautiful climate, cotton, citrus, cattle, and copper, all of which are reliant on harvesting that water. We weren't the first ones to think of it. People have been managing water in the Southwest for thousands of years. But if you go back 7,000 years ago to the cradle of civilization, the Nile, the Tigris, Euphrates, the Indus, the Ganges River, and the Yellow River in China are widely accepted where civilization began, roughly 7,000 years ago. It's the first place people started coming together in large populations, more than small scattered groups, and developed the civilization and culture. And so the civilization that we have here in the Western North America or Western U.S. and the civilization that developed 7,000 years ago all was reliant on mountain snows. This is a picture of the top left is the headwaters of the Tigris Euphrates in northern Iraq and Iran. This is a mountain range in China, which I'm forgetting the name of. I was there this summer and I can't remember the name. And then this is a satellite view of the Himalaya with the Indus River. Civilization began in sight of snows. We've been taking advantage of snow to our benefit for a long time. What is so cool about snow? I'm going to try to get through this quickly. You said 20 minutes. I like snow. Okay, what's so cool about snow and why we've been taking advantage of it since the dawn of civilization is it's stored up in the snowpack and then released when we need it. This is a hydrograph. This is a particular river in, I said I wasn't going to do this, but I'm going to have to do it. Okay, the laser pointer's coming out. This shows the average hydrograph for 30 years of record at this river. And you can see this any river that drains seasonal snow-covered areas, seasonal snow-covered mountains. The discharge peaks each spring right when we need it downstream. It's a wonderful reservoir. It's the most monetarily cost-efficient reservoir you can manage because we don't have to build anything for it. It's there. And then it's released when we need it. This blue graph is the trace for just these 3 years. The yellowy orange one is the long-term record. What we deal with in water resources and what water managers have to deal with is this variability from very good years in 2011 to horrible years in 2012 and then average years. And that's what the dams and reservoirs that we have on our rivers are trying to do. Dampen the storage that varies from year to year as we go through in time. While there's been tremendous news about the storms in the eastern U.S., there's been a lot of news. I'm a bit of a news junkie. I follow the news regularly. You see Colorado River drought forces painful reckoning, Western drought, disaster declarations. The New York Times last weekend had a feature called The End of Snow. There's been a lot of recognition that the West is extraordinarily dry, extraordinarily low on snow, while the East has been very wet. Arizona dry rivers. This is from the Daily Republic. San Francisco, the Examiner, came up with drought tips, 15 easy ways to deal with the drought. And this is risky, but this is my favorite. Is anybody here from California? Southern California? All right, look away. Okay, this was the headline at Los Angeles. Nudity is the tip for dealing with the drought. Water-saving tips. So, all right, sorry, Southern Californians. You'll have to read the paper. I'm not going to speculate. I'm not going to go down there. Okay, so when we start thinking about water and we start thinking about water in the West, there are several questions that we ask. First, how much is there? You know, how much snow is there? I like cartoons. You can look away if you don't like them or hopefully snicker under your breath. That's fine. But how much snow is there? That's the first question we start with. And this comes back to roughly 100 years of measuring snow in the United States or in North America. This guy is the godfather of all snow. He was a classics professor, trained back east, and he took a job at the University of Nevada, Reno, 1898. And he quickly realized that their water came from the mountains in the Sierra Nevadas. He's like, nobody's measuring this. Some years it's good, some years it's bad. Some years it floods, some years there's drought. So the classics professor, James Church, started measuring snow. We still use instruments today, over 100 years later, that he designed to measure snow when we go out into the field. And then this is a fun little book. If any of you like little night table books, this is a history of the tough as nails snow hydrologists who used to go out and started to make our first measurements, starting in the 1940s and the 1950s. It's a fun little book to read. This is what it looks like if you've ever been out in the forest and you've seen a large pole with an orange sign and a black slide. That's called a snow course. Those are places where we started measuring snowpack in the 1940s and the 50s, measuring it by hand. These are California Department of Water Resources. Now we have telemetry. These are little, they're called snowtail sites, and they bounce how much snow water in the weather at a local site off the ionosphere back to a master station, and creates a record of how much snow we have or how much water we have, which is incredibly important for managing water. I downloaded this image this afternoon. We come up with maps like this for different rivers and different watersheds. And this gives the percentage of water within these different environments. Colorado, as the afternoon, was doing really quite well. We're not doing very well here, and you can see that the Sierras and the Cascades are really not doing terribly well either. So this is incredibly important information for water managers. But there's 700 sites that go into creating this map. Those sites are roughly 6 feet across. You could put all those sites within the stadium on campus. That's all the information that we have from regular measurements over time. This is a huge area with relatively sparse measurements. So what we do is we try to understand things with remote sensing with airplanes. This is a spectrophotometer, which is looking at the structure of the snowpack, relating it to what they see in airplanes and satellite images. These are the Sierra Nevadas and Mono Lake, and this is actually Arizona. You can see the Mogollon Rim. You can see just the Gulf of California down here. And this particular image is showing the difference between wet and dry snow. We want to know if it's melting or if it's not. So we're trying to gather more information on how much snow is out there to supplement these little points that we have in space. What are we seeing when we look at these little points, when we take all the data that we have? Many places have less snow. April 1st is historically used to allocate water resources. Many places have less snow, so these guys out measuring snow at one of our study sites. That's what they're seeing. Many places are getting more rain and less snow. That's what this figure shows here. Red colors mean that they're getting more rain. Blue colors means that they're getting more snow. Most of these sites seem to be getting more rain, which isn't so good because that water's not being stored in the snowpack anymore. And then snow is melting faster. The flowers are coming out earlier, which is nice, but when the snow melts faster, we have to manage it for a longer period of time to use it throughout the summer. So those are the patterns that we're seeing in how much precipitation is out there. Now, the second question is, after how much is there, we want to know what happens to it. You know, and this is a continuity equation, a simple hydrology equation. And all this says is that precipitation, or the snow, can go to a bunch of places. It can evaporate, it can be used by plants, it can recharge groundwater, or it can come out in a stream. That's all it's saying. What we know is that small changes in how it's partitioned can have a big impact on how much water there is. And here's my one science slide for the science and engineering geeks here. What we do is we try to understand at one point how the total amount of snow that accumulates over a season distributed across steppes is affected by changes in climate and local forcing on an energy balance and predicts melt. And that's the last of the science and engineering for the talk. Although if there's anybody from my class in here, it will be on lecture Thursday. So, all right. So what we're doing, the things that we're doing is we're looking at snowpack structure very closely. Snowpack structure in chemistry. We're putting tracers on the snowpack. This is a picture of me from last century. I love saying that. It's nice being born, you know, across the century. This is a picture of me doing research last century. This is dye tracer to look how water moves in the snow, and these are some of my students. This guy actually came from India to take a class with us to learn how to study snow. So trying to figure out what's going on up in the snowpack is incredibly important, but not everybody, people want to hold on to their water in the West, and so we come out as no trespassing, survivors will be prosecuted. Not everybody wants us out there measuring snow, so it's just a fun little photo that when we get all dirty and grumpy and we go out and we ski in the field, we're not always welcome. What is it that we learn from all these measurements and these observations that we're taking about those processes? The first thing that we know is when we look across this region here, which is what feeds the Colorado River and the Salt and the Verde, where we get our water, is that more snow is evaporating before it melts. We call it sublimation. Some people have a little problem getting their handle around that. It has to melt first and evaporate. But this is a picture of ice cube trays that have just been left in the freezer for a long time. Now, if you do that, if you go home and do that, and you come back in a week or two, you'll see that the ice cubes have shrunk. And that's because the water has gone from the ice into the vapor phase. It's evaporated. So what we're doing is we're seeing more of that water evaporating and not being there at the end of the season. One of the good things that we're seeing, this is some of our flyover data where we have very high resolution, and the red shows areas of shallow snow and the blue shows area of deep snow. What we're doing to understand that and compensate for that increased evaporation is thinking of new ways to manage forest. So we know that this is a problem, and we know we want to grow forest in clumps, not individual trees in a park, and not just a complete expanse of trees, but we want to grow them in clumps. Because when we grow them in clumps, that protects the snow so we get more water in the system. Of that water that we get in the system, we know that we only get about 10% in our rivers. So understanding that vapor flux, what's lost back to the air, is incredibly important. Only 10% contributes to the rafters here or contributes to filling our reservoirs. So a small fraction of what falls is what we have to work with downstream. Anything that we can do to change that will give us more water. And those are some of the things that we're working on now. We know that if we look at the chemistry of the water, we're sampling the chemistry of the snow, we're sampling it when it melts, and then down in rivers. We know that the snow doesn't run off the ground and go into the river. That's what we thought. That's how we manage our resources. But now we know that that's not the way the water gets into the stream. Water goes into the ground. I like to think of it as a sponge. Wipe your counter with the sponge and it holds a bunch of water. If you use colored water when you put it in the sponge, you then run it through the sink. The clean water goes into the sponge and the colored water comes out. And that's the way our streams and rivers are. So we have this buffer of water moving through the sponge or moving through the subsurface. This is a map of the Tucson Basin, which shows the groundwater decline. And this groundwater is then that water, that snowmelt, that infiltrates into the ground and is stored in the sponge. Our basin here, this is the U of A, we're just over here. So this is the groundwater map and how far we've drawn down that snowmelt that filled that up over thousands of years. And then the last little part that we do is, as we know how much snow is there, we get a better idea of how much snow is there. We get a better idea of what's happening to it. How much evaporates, how much goes into the ground, or how much goes into the river. Then we have to sit down and make better decisions about how we choose to manage. So as scientists and engineers, we can help with understanding these parts, but everybody needs to participate in this. It's a cost-benefit analysis. It's choices that society has to make. And so I like to think of this as water flowing down a hill or knowledge flowing down a hill. We have two sources of knowledge, and then we have how we make decisions when we put that knowledge together. And then, if nothing else in this talk, hopefully you'll support the idea of snow research and think that snow is important, even if we live in Arizona. And every time you take a sip of water here in the future, you'll recognize that you really do love and appreciate snow when you drink that nice cold glass of water. Okay. It's a little long, but not too long.